Hey, fifth graders, we are in our Unit 4 packet, and we're on page 2, and we're going to look at some patterns with fives. So we've already seen that when we're multiplying a multiple of 10 by a multiple of 10, that you can multiply your non-zero digits and then just put those zeros in after, because every zero you see is like multiplying by 10, and we're shifting those digits over one place left. Something kind of unique happens when you multiply by fives, though. So let's solve these out using the strategy that you learned from lesson 1, and then we'll talk about the difference that you see. So first off, with 50 times 2, I notice, hey, 50 is a multiple of 10. It ends in 0. That means I can multiply my non-zero digits. 5 times 2 is 10. And then place my 0 in after. So 50 times 2 is 100. And yes, 50 plus 50 is 100, so we know that's true. For this next one, I have 50 times 20. These are both multiples of 10, right? So we can multiply our non-zero digits. 5 times 2 is 10. And put in our zeros after, and I see 2 zeros. 1, 2. We put in our comma, and 50 times 20 is 1,000. The next one, we have 50 times 40. They're both multiples of 10, so I can multiply my non-zero digits. 5 times 4 is 20. And then we have 2 zeros. And 1, 2, 3, put in our comma, 2,000. For 50 times 600, those are both multiples of 10, so we can use this strategy. I'm going to multiply my non-zero digits. 5 times 6 is 30. And then we put our zeros in after. There are 1, 2, 3. 1, 2, 3. And we'll put our comma in. And last one, 500 times 800. We multiply our non-zero digits. 5 times 8 is 40. And I see 1, 2, 3, 4 zeros. 1, 2, 3, 4. We put in our commas, 1, 2, 3, and we get 400,000. So now what I'd like you to do is I'd like you to look at these products here. That's the answer to a multiplication problem. And I would like to know how these products are different from the multiplying by 10 patterns that you saw in lesson 1. So how are these results different from these results? So go ahead and press pause and think about that. Discuss it as a class. And then press play when you are ready. Okay, welcome back. I am hoping that maybe you noticed there seems to be an extra 0. Okay, so when we look at this, in 40 times 3, there's 1 0 in the problem, there's 1 0 in my answer. 2 zeros in the problem, 2 zeros in my answer. 3 zeros, 3 zeros. 2 zeros, 2 zeros. 4 zeros, 4 zeros. But when we look at this, there's 1 0 in the problem, but there's 2 zeros in my answer. And here there are 2 zeros in my problem, but there are 3 in my answer. Same thing here. There's 2 zeros, but there's 3. 3 zeros, but there's 4. 4 zeros, but there's 5. So how are they different? Well, it appears that there is an extra 0. It appears that there's an extra 0. So my next question is, do you think this happens every time we multiply by a factor that has a 5? So press pause and maybe discuss that. Do you think this is going to happen every time we multiply by something with a 5? Because that's what all these have in common, right? Okay, press play when you're ready. Okay, maybe some of you said yes, maybe some of you said no. I gave us some problems here to test it out. So let's do 5 times 30. And I see 30 is a multiple of 10. So I can do 5 times 3 is 15. And then there's an extra 0. I'll put that there. And here, 50 times 50. 5 times 5 is 25. So we multiplied our non-zero digit. And I would put 2 zeros after that. So 1, 2, 3. It's 2. Sorry. It's 2,500. For 50 times 700, I would multiply my 5 and my 7. That's 35. And I see 1, 2, 3 zeros. 1, 2, 3 zeros. 1, 2, 3. And the last one, 5 times 9 is 45, and I see 1, 2, 3, 4 zeros that weren't used, so we'll put those in. 1, 2, 3, 4, and we get 450,000. So in these, we're multiplying by a multiple of 10 that has a 5, right? And do I have an extra 0 in my product? 1 0, 1 0, 2 zeros, 2 zeros, 3 zeros, 3 zeros, 4 zeros, 4 zeros. No, there does not seem to be an extra 0 in this product, but there are in these. So my question is, why? Why do these products have an extra 0 and these products do not? So press pause, discuss this. Press play after your discussion. Okay, welcome back. So I am wondering if you noticed that all of these 2, 2, 4, 6, 8 are even, right? So those are even, and these 3, 5, 7, 9 are odd. What happens when you have an even number of 5s? Meaning you have 2, 4, 6, or 8. Well, every time we have, yes, write this, 5 plus 5, we get 10, right? So for every pair of 5s you see, we're going to get an answer that ends in a 0. If I had 4 5s, I would have 5 plus 5 plus 5 plus 5. This is an even number of 5s because I can pair them together, right? Evens mean it has a partner. There's no one left out. 5 plus 5 is 10. 5 plus 5 is 10. 10 plus 10 is 20. That ends in a 0. So 2 5s are always going to make 10. And when you add multiples of 10 together, they always end in 0. If you have an odd number of 5s, though, like 3, 5 plus 5 plus 5, 5 plus 5 is 10, but 10 plus that extra 5 would be 15. There's not an extra 0. So basically, if you notice when you're multiplying that all of a sudden in your product, it seems like you have an extra 0 when there's only 1 in the problem, that's probably because one of your factors had the 5. And when you have 2 5s, they make 10s, and every time you have a 10, that's going to create that extra 0 that you see. So don't be alarmed if you see that happen where it appears to be an extra 0. You just follow the strategy that we learned. Multiply your non-zero digits. 5 times 2 is 10. And then there's 1 0 to place after that 10. All right, thanks for watching. Talk to you soon.